Disruptors and curious minds, welcome to the moon. On today's show, we are reading the NASA Moonbase User's Guide. Yep, a user's guide to building the moon infrastructure that will eventually lead to a full-time human civilization. Well, no, they don't call it a civilization, do they? They call it a
presence, full-time lunar presence
on the South Pole of the moon. We're going to look at it. We're going to look at the technology, what seems feasible, what seems like a distant pipe dream. We're going to look at the economics of it and ask why, and maybe ask what the document is missing in the process. The very idea of a user's guide to a moon base is pretty special, isn't it? You can't imagine NASA in the 1960s releasing these kind of user guides to the program.
Yeah, the language is awesome, and it's really an interesting start for coordination. We talked about in a lot of our Space to Grow breakdown of that book in book club, and we read Philip Metzger's paper. We had Philip on the show. Coordination is an interesting piece, and this user guide is NASA's push out to be the coordinating entity.
Well, it says, doesn't it, the following pages outline how NASA and its partners can empower the moon base effort using these resources to guide their investments. It's very much laying out them. It's not us, it's all of us are building this, which later on we'll get to, I think, raises some interesting challenges as well, depending on how many partners they're using, but it definitely opens up challenges to the tech.
Well, and references in the document to CLPS, the Commercial Lunar Payload Services, which is the partnership with external entities and not government only, but government plus outside entities. That's how this thing's going to happen. 3 phases, like you mentioned.
Yep. Phase 1,
a lot of launches.
Phase 3.
A lot of launches, a lot of landing.
Is it a lot of launches though? So phase 1, 25 launches. Phase 2, 27 launches. Phase 3, 29 launches. SpaceX will have done 29 launches by the end of the week.
Maybe not a lot of launches. I did a lot of internal comparisons to the Metzger paper of bootstrapping the space economy, and I think one of the big differences I landed on between this document and what he was presenting an economic plan, a scalable economic plan. This is, hey, we're going to the moon. We're going to figure out what gaps we have to understand. We've got some challenges to overcome, and we're going to do it in steps by proving that we've overcome the gaps, the technical challenges, the architectural challenges, and we're going to put a base on the moon, and we're going to have people hang out there.
It doesn't mention the price, does it? It doesn't mention the timelines. It doesn't really get into the economics. It mentions a cislunar economy, but it doesn't outline what that might look like. And as we've learned, making money in space with those killer stag applications isn't a given. So it's very much more about this is what we need to do technologically, technological wise to make this moon base happen.
Yeah, one question that kept ringing in my head was at what point does this moon base go from like a cost center to a value generator from an economic perspective? Because this goes beyond, hey, we're going to the moon. There's such a push for the space economy and cislunar economy and LEO and Earth to space economy, space to Earth economy. It's interesting to see.
Does it need to? It's a stepping stone to Mars. Does it need to make money? At what point does it need to make money?
There's going to be at some point people are going to look at the cost for some of this stuff and they're going to go, we can't support this as a government, right? Which is why they have the ecosystem, the partnerships, and the enablement that's CLPS and all the other programs have done. I'm not squashing this at all. I think this is great that it's kind of this organized document. I love they call it a user guide.
Here's a question for you. So I'll push back on that. Phase 1, 25 launches. Phase 2, 27 launches, and then you have the landings as well. Is that enough? Doesn't seem very many launches to build a full-time human presence on the moon going from now. Doesn't feel like a lot. I mean, yes, they're increasing the weight. If you look at the payloads on those launches, so in phase 1, they get 400 kilo payload to the surface. So that's 25 launches, 4,000 kilos. Phase 2, that's ramped up a lot from 4 to 60,000 kilos. And then phase 3, 150,000 kilo payload to the surface. Philip Metzger's, he did say you only need 12 tons, so we're in there.
Right, right. No, I don't know if I mean, yeah, I guess when you think about it, in the grand scheme of like SpaceX launches, it doesn't seem like quite a bit, but launches with such a purpose, like SpaceX launches go up, they push something in outer space and they're kind of done. This is a launch, maybe dropping a lunar lander, maybe putting something in space that allows ships to refuel in some way or some format. Yeah, I guess they got some goals
Well,
in
let's
each of
look at
these
those
phases.
goals.
Yeah.
So phase one, achieve high rate reliable surface access, establish ground truth for moon based landing sites, experiment and
Hold
test
on one second. What is
capability. Yeah.
hold up. What is ground truth? What does that mean?
Does that mean the right location?
That's all right. It's an interesting way to
Establish
phrase it.
ground truth for moon based landing sites.
Yeah, I mean the South Pole has its challenges from a that we'll go into, I guess, in here. So maybe it's finding the right spot to build the thing. Maybe, yeah. Site selection on the moon, real estate specialists.
Site selection. There
Site
you go.
selection on the moon. There's a whole new industry there for you.
There you go. And the first crewed moon based mission. Then things ramp up with the way phase two, establish initial lunar surface infrastructure, increase CLIPS payload mass capability, technology demonstrations, which going back to our episode with GRU and Hotels on the Moon, they were all about technological demonstrations. Then semi-annual crewed missions. And then phase three, regolith manipulation and site preparation, again, increase CLIPS payload mass, uncrewed cargo return capabilities, and then continuous crew presence.
So that third phase is when we get into the in situ resource utilization that High Frontier talked about, that Metzger talked about, that Grew talked about, making bricks in space.
Regolith manipulation and site preparation.
Yep.
How much of that will be autonomous? So yeah, they're very broad brushstrokes. I feel
Hmm.
that's very broad. It's we're going to do this, this, and this. We'll
That's
leave
where you got to
reality to
start.
the
Yeah. I
side for
mean,
the moment. Yeah.
yeah, that's where you got to start. I think it's cool.
Moving on. What are the challenges? This was quite surprising. Environmental challenges.
Yeah.
Light.
I originally looked at I read that really quick this morning and I thought it said lightning. I'm like, lightning? What the hell? No, but actual lighting. So the South Pole has challenges, right? The terrain is funky, and it's very dark. The way it sits, it gets very little sun. It's cold. There are a lot of craters. The terrain is very tricky to navigate. So, but
Pointing out the obvious there, but yes.
there's obviously other reasons for selecting the dark side of the moon, as Pink Floyd would lead us.
Maybe this is connected to your truth questions, where in the light, and now I can't stop saying lightning, in the lighting and terrain section. So systems operational paradigms and site plans must be robust to the challenges presented by lighting in the lunar South Pole region. Areas of interest for technology development include heating and power solutions that allow systems to survive the lunar night and explore areas of permanent shadow. Operational considerations include new shadows cast by in-place infrastructure, so they're creating their own problems there. Is all that just for the early phases? What happens when the humans get there? All of that surely is one thing, making it all safe for your rover, but making it all nice and safe for your humans, different ball game.
That's a fact. That's a fact. So, in big and bold, right underneath the challenges lies the word interoperability.
Interoperability.
Such an important word in the world of coordination and standardization, and there's a lot of really cool parallels to this. I did some nerd research on this, Mark.
Oh, like it.
So interoperability, the questions become, okay, who calls the ball on the standards? Is it prime integrator based and someone big gets up there and says, hey, here are how all the connections work. In order to work in our ecosystem, you have to match what we do. But guess what? We're the best makers of those things and widgets. So we're going to be able to provide everything. And it's kind of a sole spec situation. That could be driven by funding. That could be driven by who's doing it the quickest. But then you also have the idea of interoperable standards take a long time to come together. They take consensus, they take committees, they take agreements, they take making sure participation, like it's open participation, right? That happens here. Let's point back to the Civil War. Let's rewind. So
Wasn't expecting that.
I learned about something called railroad gauges.
Right,
Railroad
yeah.
gauges, and railroad gauges aren't like circular gauges that have a readout. It's actually the width of the tracks, the width of the railroad tracks, right? Pre-Civil War, all the different railroad systems in the United States had different gauges. I built a different gauge than you because I don't want your trains running on my infrastructure, which is, I'm
But
protecting.
welcome to Europe. That's still you can't. That's one of the problems with high speed rail in Europe is that the gauge in the UK is smaller than in Europe, so you can't run your trains from one country to the other. That's
Okay.
still a thing.
Very interesting. Okay, so I did not my tiny little window into the world obviously forgets the European side of the fence a lot of times, and so the challenges still lie there. A couple of interesting pieces, right? That obviously these places where the gauges were different created cities, did really cool things because people had to stop off, they had to unload, they had to do all these different things. But what ended up happening, Civil War was like, yo, guys, we got to get our shit together here. Some standards got put out. They really didn't happen until after the Civil War. But that is a point back to how it started as this. I'm investing in this stuff. I've got money. I have investors. I'm going to try to maximize who's allowed to use my stuff and how I can monetize it. So we don't want to do that necessarily when we go to the moon. We got to figure out kind of a better way. But my question to you, Mark, is what is the catalyst that will eventually drive the need to truly interoperate between all of these entities, between the countries, between the companies, between the entrepreneurs? What's like that forcing function that makes us do it?
Short term or long term? Short term, China and the race. Long term, the, the deterioration of the planet to such a level that we need to move civilization off planet. That would force our hand. Economic incentives. There'll be an incentives between the private sector to you'd hope to make that work if you've got SpaceX and Blue Origin and Zona and Axiom and rocket fuel and rocket everything else. And if they're all building the infrastructure, hopefully they are designing some kind of interoperability. It's like plug and play in space. Hopefully they're doing that. That's the incentive. But I don't know. What
Lego,
do you think?
Lego, where are you at?
What do you think? What's the push?
Well, I think
I mean, it's in bold in this document. It's obviously front of mind.
it's really going to be interesting to see who comes out and what kind of entity is pulled together, because you have things like IEEE that put together wireless standards and things like that, and again, it takes a long time to do it the right way.
Maybe it doesn't take a long time anymore. Maybe this is the thing where all the timelines have been shrunk down so much that one format is chosen and everyone goes with it, and you don't have this bickering and infighting. That the scale of the ambition is too important for that. It's not
But
like
so
on
much,
Earth where you can't take the train. You can't take your train from the UK to France.
yeah, yeah. So who's the Fedor Martins of inner space interoperability? There's your question.
NASA or SpaceX, surely they'll be the the arbiter in all of this.
Yeah, or what'll happen is they'll have an additional nonprofit created as a lab to figure this out, and then the lab will get co-opted and yanked and turned into a for-profit organization like we saw
It's
in
a
AI.
massive thing but it's a massive thing if you read this bit. The moon base will comprise systems developed and built by many providers across government, industry, academia, and international community. Ensuring compatibility of the interfaces between these systems will accelerate progress through the phases of moon-based development and efficient use of resources. This bit is key. The collaborative development of interoperability standards for lunar systems like power, docking, and communications will empower effective partnerships and foster. Okay, power, docking, and communications in space. It's huge. This is not like plug and play your laptop into the wall. This is space centers. Space like it's a huge challenge.
The idea it'll eventually be, everything that gets made has this certain connector type. Everything that gets made has this certain power spec, has this certain communication spec. So we're going to see, I mean, I don't know, we're going to see, I'm not going to predict, but we might see something as interesting and groundbreaking is like the 1990s telecom build out, like all those networks and how those got built out and this how the specs were written. And we've done stuff like this before. We just haven't done stuff like this above our heads, in space.
We've spoken about hair and stag and the economic incentives. Is this an incentive? Is this the economic incentive for somebody? Is
Well,
this the stag?
here's the tricky part. A lot of the differentiation between products and companies and the strive to invent something with amazing efficiency, low costs, ease of use, all of that stuff. We're all kind of trying to do that as individual companies that are funded by different investors. And how does one shake out to say, hey, we're gonna do this and exclude everybody else that's trying to do this? But at some point you got to be like, hey, how are we designing the seatbelt here, guys? Like, how are we designing the airbag, as a
Well,
reference
yeah,
to.
but the seatbelt and the airbag, that they're talking about nuclear reactors. They're talking about rovers across planet. They're talking about logistics systems and moving manned spacecraft between Earth and the moon and back again. They're not talking about seatbelts. They're talking about mega complex tech in outer space.
Well, the seatbelts in the airbags are pieces and parts of the complex tech. It's just busted them out.
Yeah, but it's easier to come to an agreement about what your seatbelts should do than your robotic arms bringing satellites or bringing stuff on and off the surface, and then SpaceX fly in and Blue Origin fly in and like, oh shit, we can't do it because you've got the wrong size plug.
Well, imagine before cars were cars, and someone
Yeah.
mentioned like an airbag. Like, what the hell is that? Like, how complicated is that? So I don't know. I'd push back on that a little bit. On to the
What about
gaps. What are the gaps? Talk about the gaps.
the gaps? Okay, functional gaps.
Mind the gap, Mark. Mind the gap.
Mind the gaps. Tech and data gaps. Be careful when walking onto the lunar surface from your capsule. Mind the gap. Hope they've got enough data on what's underfoot. Talk to me about functional gaps, Jeremy.
So they basically listed out the missing pieces and parts to figure out how to get phase 1, 2, and 3 pulled together. They've got categories. They've got it spelled out pretty specifically. As I look at this, Mark, is this is as much a like an execution plan on how to do what they want to do as much as it is like a market plan for people building in the space economy. This is demand. Like
Yeah, this is what we need.
this is a demand statement. And like what is really interesting is this a bat signal to space innovators to basically be like,
Call to tender. Yeah.
right, right.
It's an interesting thing. It's a good way to put it. Yeah, it is, isn't it? We need all of these things. They've got, okay, there's a lot of things. There's a lot of gaps. They turn into tech gaps. Okay, technology that doesn't exist now or is in a very minimal version of what we need. And then you have data gaps, which was more surprising. There's not enough data on the surface of the moon, so we don't actually know what we need and what's there. So functional gaps: perform robotic manipulation of payloads, logistics, and/or equipment on the surface. Okay, that's a pretty big functional gap. That's all of it. Interface robotic systems with logistic carriers on the lunar surface. Control robotic systems in sunlight areas and non-PSRs on the lunar surface from Earth. Radio controlled robotic systems on the dark side of the moon. Provides, so they're pretty big technical gaps.
Well, look at the interesting piece here, and this is a call out to Metzger's discussion that we had on the show, and what he's doing. It is, I don't remember if it was like an economic center or opportunity center for space tech entrepreneurs. I mean, you look at this list, and you don't just see the list. Like, think about the things that connect the things on the list, like the connective tissue between all of these things to make them work. You have these as independent systems, and then the coordination of independent systems, and
And
there's
the
a
interoperability of all of that. Yes.
right, right, right.
if
Uh,
I look at all of these gaps and then I go back to the beginning of the document and look at the phase 1, phase 2, phase 3, and this is what we're going to achieve, and then I scroll back down to this, and no, that's pretty much everything. Where
yeah,
would you begin?
Did you list all these systems? So the big categories are
No.
let's run through them. So autonomous systems and robotics. We have communications and positioning, navigation and timing. You have habitation systems. So, where do we live? Or logistics systems. So how do we move stuff around on the moon? Mobility systems. How do we move people around on the moon? And what else? Is that it?
Robotics and remote autonomous robotics. It feels to me that, I mean, they all link together, don't they? You don't have one. It's like a house of cards. You need them all. You pull one out, you don't have the house of cards. But robotics seems perhaps the most readily traversed. There's a lot. It's a huge industry. There's a lot of people working on many autonomous robotic problems specifically for space. You mentioned this being a call to arms, a marketing document. There will be people working on all of these right now.
Yeah, how well positioned is like Figure, and how well
Yeah.
positioned is Optimus, the Tesla robotics arm. And I did some additional research on this. There was another paper called the architecture. There was a white paper in here. Let me find it.
From
Architecture
NASA.
driven. Yeah, from NASA that was referenced here. It's in a QR code down in the document, but architecture driven tech gaps white paper. And in that document, they called out like 56 different gaps initially. I think that list maybe had whittled down into what we're seeing in this user guide, but they prioritized in this architecture driven tech gaps white paper like the top 5 gaps and
Okay.
challenges. Do you know what the number one listed as top priority was according to that white paper? Philip Metzger referenced it when we were talking in our interview with him.
Logistics, power, robotics, habitation. Launch? Are we back there?
Dust.
Dust, of
Dust
course.
dust tolerance is the number one priority listed as the gap in according to architecture driven tech gaps white paper, which is listed down below in this user guide on a QR code if you want to read more about it. But you remember when Philip Metzger was talking about how every time something gets launched, it shifts moon dust and regolith everywhere. And one of the most
Or
important things,
lands, yeah.
or lands, yeah, all of that. And it doesn't just shift and go away, it like hangs there, right? And it gets into antennas, it gets into so how regolith proof are Tesla's robots? How regolith proof are Figure's robots? Do they have groups working on some of this stuff? And if not, does someone grab maybe a license to that technology to make a moonproof version of that?
When you watch, and I think Starship have just done some dry blasts, and obviously Artemis 2, the launches, even if you imagine a tenth of that landed on the lunar surface, it's going to kick up an almighty storms. Perhaps that's why there's so few launches and landings compared to SpaceX in the document, because they realize if we can't keep doing that, because we're just going to destroy all our work by landing all the time or taking off from the moon's surface. Seeing as they're not going to be able to make some kind of inertia drive, and then you have to rely on rockets, seems like an almighty big problem to fix. What's
So
the top
there,
five?
there, wa-
What's the
there,
top five?
well, let's figure out the dust thing first. So imagine you and I in like spacesuits with backpacks, just like sucking up dust that are around there. That could be a whole freaking industry collecting and clearing the lunar. Is it even do you even say atmosphere? I don't even think you probably say atmosphere because it doesn't have any.
Air.
The
It's not
the
air, is it?
Yeah, it's just
Vacuum.
the
The
space
vacuum.
around the moon, right? That could affect equipment and such. All right, you want to hear the
Hold
other?
on. Since you want to stick on the dust for a minute, is there a comparable challenge on Earth that the technology could be used to solve that could be
Sandstorms?
taken up? Okay, so how do they? Well, do they have any technology on sandstorms, or do they just let them blow over and wait till they disappear? But then
It's a
you have the atmosphere, so it's not the same issue.
it's a
It's
great
good
question.
training ground.
It's a great question. Great question. All right, so let's run down the top 5. System survival in lunar shadow. So that reference, I mean, that's one of the gaps that's called out. Communications, really important. You really can't do much with that. Mars transport propulsion.
What does that
So
mean?
really trying to figure out how, once we get established on the moon, how we get from the moon to Mars. And I
Mass
think
drivers.
be kind of wicked, dude. Did you say anything about radiation protection in here in the habitation systems?
No, nor is there anything on the human factor as well on that. How do you
Yeah,
protect
well,
the tech?
I think this is an opportunity for them to fill some of the gaps related to, what is prolonged life on the moon. Yeah, I mean, I guess that we have data on what happens in the ISS and people that are out there for a while, but what is prolonged effects of living on the moon look like? Is it the same? Um, that sort of thing. So let's see. Let's peek just real quick at some of the ones that could be really interesting to peek at. So the positioning, navigation, timing one, I think that was under communications. Could that be an opportunity for our friends at Inflection with their quantum clock?
Quantum clocks. Don't need GPS with quantum clocks.
Yeah, this essentially is like the equivalent of like lunar equivalent of GPS. Like, what does that look like? That could be really cool. Um, let's see, pressurized logistics in fluid transfer. So this is in the probably habitation logistics, probably in all of them. So this is like plumbing problems, right? But you're in the vacuum of space. No interoperability standards. So kind of whoever writes the standard, whoever has the tech maybe writes the standard, or whoever has the standard develops the tech. Um, some terrestrial comparisons, right? We talked about railroad gauges, electrical outlets, shipping containers, ISO standardized on shipping containers, right? So that's some of that as well. Power distribution and storage. So generation gets a lot of attention, right? We've all heard about solar arrays, nuclear, all of that, but like distribution and storage, that's going to be pretty interesting to help them figure out this survive the night problem. 120 hours of lunar darkness, right?
Moon batteries. Moon batteries.
Ooh, back to the electric stack, huh? Back to the electric stack. And last one I'll bring up here as interesting is the regolith processing in ISRU. So in situ resource utilization, that brings up GRU, building the bricks, processing the regolith. Also Glenn Martin, right? Talking
Yep.
about taking helium-3 out of that. But is there anything listed in here about like how we get oxygen from regolith ice? Is there anything like how we get how the oxygen piece happens?
Specifically,
Yeah, that could be something. A lot of opportunities, space entrepreneurs.
that's
Take this and
resupply.
run with it.
It'll be in resupply, won't it, initially?
Yeah. All right. Well, or do we go to Mars forward? Talk
Well,
us
yeah,
through
the
that. How's this a
Mars
jump off?
forward.
Yeah.
So all of that, nothing. It's just an engineering problem. All of that. So once that's all ticked off, then and the moon becomes the launch pad for Mars. The moon base will empower NASA to develop, test, and demonstrate needed technologies, capabilities, systems, and operation paradigms for future human missions to Mars. And then they outline nuclear technologies, independent operations, human factors, logistics, dust, planetary systems had the same problems, but ramped up onto a scale beyond our imagination. So, nuclear technologies, developing moon-based nuclear power systems that will annoy some people. Empower Mars exploration, where NASA's already selected nuclear fission as the primary power generation technology for its robustness to the planet's environment, i.e., to dust storms. These efforts also benefit nuclear propulsion development efforts for Mars transportation systems. They've chosen fission because they can do that.
Yeah, I think that as we try to kind of pull all this stuff together, thinking on paper, we would be remiss if we didn't think about the human systems and structures required for this continuous presence on the moon. Like not just like what it does to the human body, but like the social structures and the systems, because you'd almost figure that every one of these technological gaps has like a social system gap to it as well. Like so
What do you
once we
mean?
like if there's going to be a bunch of people on the moon doing work, being paid by different companies to do work, what does that look like? What is the responsibility for them being there, and how do they hang out? How do they how do they live? What's meaning on the moon? And like, yeah, I don't know. Just a lot of those things that maybe we do a social system parallel to the user guide. Okay, this is how you build it, but this is how humans move within it. Could be
Well,
interesting.
it reminds of that episode that we did with Andreevan, who was speaking about the important human elements you need in any long distance, isolated human endeavor, whether that's walking to the North Pole or flying for 6 months to Mars. And you need, well, remember very
Guitar
commonly in that
players.
we need guitar players, you need musicians, you need comedians, you need people to, if you just send a facsimile of a astronaut who then you're going to get problems, you need a cross section of society for those long distance missions. I think you've hit the lunar nail on the head with this, as this is a call for this is what we need. It's a bat signal to the space industry, and I think you hit that perfectly. Question for you, Jeremy: have you read the Chinese moon base plan?
Ooh, is there one?
Of course, there isn't. Not it's not to our not available to our eyes.
There will be one very soon.
There will be one, and
Because it's a race. It's a race. Buckle up.
it seems from a geopolitical point of view, this is all global political posturing as well as a marketing document or a call to tender, a call to arms. This is what we need. But it's also, once it's written down on paper, once they've thought on paper about this, it makes it more real, it makes it more tangible, it makes it more accessible. It's not in your head anymore. It's written down in a user guide that anyone can read. This is what we're doing. And you got to act on that now. And the Chinese will
Thoughts
be
into objects, objects into action, my friend.
exactly thoughts into objects, objects into space stations.
Yeah, this is cool. This is a great find. Super timely. That picture right there that you see was taken by the last Artemis crew that was up there, Artemis 2 crew, of the Earth setting, which is what a perspective to end the show on, Mark.
Yep. Thank you. And stay tuned for more space exploration at Thinking on Paper. Many of the companies, many of the people that we've spoken about and mentioned in this episode, we've had them on Thinking on Paper. You can find those links there, thinkingonpaper.xyz, to listen to those. And until next time, be disruptive, stay curious.
Keep thinking on paper.